All right, more parametric equations with calculus. At the end of this lesson, you'll be able to find the arc length of a function represented in parametric form. All right, once again, we could easily put something that is in parametric form into y equals form and then use the arc length formula, but we don't really need to do that. We do have a formula that we can use if we have a function represented in parametric form, and you'll notice it says if a smooth curve C is given by x equals f of t and y equals g of t, such that C does not intersect itself on the interval from a to b, except possibly at the endpoints, then the arc length of C over the interval is given by this formula. And you'll notice it's very similar to the arc length formula. If you recall the arc length formula, our other one looked like from a to b, and it was 1 plus f prime of x squared. So notice the difference is we're going to square the derivative of the x value plus the derivative of the y value squared, and then we'll do that instead. So it's very similar to our formula, but it is just a little bit different. Okay, so if we're dig into this one, it says find the arc length of the curve x equals t squared plus 1 and y equals 4t cubed plus 1 on the interval from -1 to 0. So we just simply need to do my length will equal, it's going to go from -1 to 0. When I set it up, the derivative of the x will be 2t, and we'll square it, and then plus the derivative of the y part will be 12t squared, and we'll square that. And if you would like to simplify that first, go right ahead if you find it easier when you're plugging it in your calculator. Otherwise, we're just ready to plug this right into our calculator. It will be a calculator section problem, and when we do that, we get a length of 4.149. And that's pretty much it. So hopefully now you can find the arc length of a function given in parametric form.